Hi and welcome to this tutorial on the functional groups. Just going to give a brief overview of hydrocarbons in this particular tutorial. So if we look at this functional group here, we've got the alkanes, and alkanes are the most straightforward one. They're the totally saturated carbon, so it's a tetrahedral carbon. It's got 4 bonds around it, and it's usually denoted as an R group or something like that, and we call it an alkyl group. And the examples of that are methyl and ethyl, sometimes denoted as Me and ET, so organic chemists always try and abbreviate when they can. So the next in the series is alkenes, so just get rid of this. Okay, so alkenes are the next one in the series, and alkenes are denoted by carbons with double bonds in them, and a double bond represents a unit of unsaturation. And what do I mean by that? Well, basically, if you look at that carbon, each individual carbon, and you put R groups on. R group, remember, is an alkyl group, so it can be anything. You notice there's only 3 atoms now around, so imagine the R groups of carbon. There's only 3 atoms around each individual carbon there of the carbon double bond. And that gives it a nice flat structure as well, if you did this in 3D. Okay, so that's the alkenes, and they normally have the suffix or the ending of the word as "ene". An example of that is ethylene. So if I was to make up a molecule now, let's take this double bond here, add an alkyl group at the end. Well, instead of putting R groups, I'll put this ethyl group there, and I put CH3 group here, and that is 5 carbons long. That's 2-pentene, or more correctly speaking, trans-pent-2-ene. Okay, so the next one in the series is the alkynes, and the alkynes have got triple bonds, so they've got an extra unit of unsaturation, making them quite flat and linear as well. Okay, the next in the series is the benzenes, or the phenols, and they're denoted just by a benzene ring really, and the example given here is cumene, and you've probably all done that as Friedel-Crafts reaction and put the alkyl group on. Cumene is just an actual product really found in crude oil. So we draw the benzene ring. You've probably come across as what's called the kekulé structure, and we put double bonds in there, and if you've done this at school, then you've done the resonance of the double bonds, where basically it goes around so those double bonds can move, and so we draw an average structure like this Robinson benzene ring, using a circle instead. It doesn't matter at this stage what you use. Organic chemists tend to use the double bond form because it's easy to write reaction mechanisms. And sometimes it's denoted as a pH, meaning phenol, so you see that abbreviated sometimes too. Okay, the last one in this series is the benzyl group, and it's denoted by this almost toluene-like structure. So it's got a benzene ring, but it has a CH2 on it as well. And this is quite common functional group in organic chemistry, because the benzyl group is often used as a protecting group in most cases. But you do see it a lot in structures anyway. You know, it's a very common functional group. So it's got its own little name, BN, if you will. And if you were going to draw this as a structure, you'd draw the benzene ring and then a CH2 like that. But like I say, it's often abbreviated in organic synthesis just to BN. So it's a capital B, a little n, that's benzyl. So I hope that gives you an overview of the functional groups for hydrocarbons. So that's all for now. Until next time, bye bye.